Very warm welcome to all. I am uploading the class today after a gap of around more than 40 days, that is 1 month plus another 10 days. September middle, I underwent a small surgery in the hand. Not a major one, but minor. Even after that, few classes I uploaded, you might have observed with a small bandage here. Then I was advised to take some rest. But unfortunately later, I had some medical issues. Again, not a serious one. Some food problem, digestion problem, not able to eat food all, etc. So nearly 20-25 days, little problem. Now I am fully okay, almost 99% recovered. I started all my activities. So now your course will continue. Just usually I won't tell all these things. See, engineering mechanics is our course. Already over. See, part 1. Force, moment and resultant. Engineering mechanics class number 1 to 41. 41 lectures already over. Lecture 1 to lecture 41 already over. Then right now we are in part 2. Actually, we are in the end of part 2, equilibrium, types of loads and support reactions. That means, engineering mechanics class, see, I am continuing here, 1 to 41 part 1, 42 to 134, already over. Last class I uploaded was class number 134, and here once again, see, class number will continue for the entire course. Lecture number will keep on changing from part to part. Lecture once again 1 for this part 2, lecture 1 to lecture 93 already over. So today is engineering mechanics class 135 main number and part 2 lecture number 94. I will tell now what I am going to do. Actually this part 2 is completely over. Still, the most important part, see, the support reactions. See, actually for that matter, everything is important. Don't think this is important, that is important. Those who are seriously learning, each and everything is important. But support reactions, it will repeatedly come later in strength of materials, structural analysis, etc. Therefore, you should have a very solid grip for support reaction. So, what I am doing now is, I am going to write first summary of standard cases covered. See, when I write standard cases here, each and everything is covered earlier. See, I explained the principle. For example, simply supported beam, a load W eccentrically placed at A from here or B from there or L minus A from there. This reaction is load into that distance divided by span. That reaction equal to load into this distance divided by span. That all I told logic, I solved by equation and finally got the answer. That all already over. So what I will do now today's class is all the standard cases which you should, what you can call it, some people call by hearting, or I don't know, some use other words. It is a bad habit, by hearting. Okay, you will remember. By heart means it should come to your mind, but remember with the principle. But now, principle I will not tell, already over. So if you get any doubt how the result came, you can go back to earlier. See, I wrote there, standard case, simply supported beam with central load, eccentric load, full span, UDL for half the span starting from one end, uniformly varying load, 0 to maximum, then 0 to maximum end to end, or 0 at the ends, maximum at center. A couple applied anywhere. Then overhanging beam, just one standard case, double overhang, only UDL. Other things all you calculate. When you do a problem later, see later when you go to SFD, BMD all, everywhere you will find reactions. But standard cases, I will make a note there. Then cantilever beams, point load at the free end, eccentric load, etc. So today what I will do is, I will not take a very long class. I will write all the standard cases here. Okay, with some statement that you separate book, you write it. For everything, principle is given earlier. So I need not explain anything. If I explain everything now, people will tell this already over systematically. Then this is today's class number is 94. 95, 96, 97, etc. What I will do is, I will give numerical problems. Everything is over, but only question with answer. That is called exercises. Maybe more than 100 or 150 I will give, depending upon the questions I feel required. See, earlier we saw sometimes very heavy loading or too much of loads. That much is for understanding. But simple cases, usually academic case or a competitive examination or even for practical case, you should how to find reactions. For simple cases, you need not struggle too much. So that all I will give. But remember, it will be called exercises. I will give enough number of exercises. Everything you solve in a separate book and make a note. Then I will change over to part 3. I have not decided part 3. Shall I go to friction or centroid and moment of inertia? On that day I will decide. See, when I come to the board on that day, when I write part 3, suddenly I will decide whichever I feel I will do on that day, I will do it. Because I never plan and come. Oh, today I should do this problem. Nothing. Therefore, part 3, or I may do friction only, because that has finished. It is not a serious subject for structural engineering. But academic point of view, competitive requirement is there. Therefore, then I will go for the most critical part, centroid and moment of inertia. After that over, I will change over to strength of materials. Okay, now I will start now standard cases. Now, standard cases of support reactions for simply supported beams. See, here, this way, two simple support, or beam with hinged support at one end and roller support at the other end. Roller means in the horizontal plane. Now, one note you have to write. We are bothered, right here, only vertical reaction for simply support beam, and later for cantilever vertical reaction. This is for simply support beam. For simply support beam, whether it is simply supported, simple supports, or hinge and roller or interchange, we are bothered only about vertical reaction, that is, which are required for SFD, BMD and deflection, bending stress, etc. And vertical reaction and reacting moment for cantilevers, little later for cantilevers. Right now in the standard cases, right here, we are not bothered about horizontal reaction. I told so many times, see, simple support, vertical reaction, hinge and roller, vertical reaction, horizontal reaction, normal reaction, vertical. Remove horizontal reaction, once again vertical reaction. So all these cases, today's standard case is only for vertical. So therefore, I will not show hinge and roller. I will everywhere show simple supports. Okay, one more note. When a couple is applied, sometimes reaction will come down at one support. Some people ask doubt, sir, how downward reaction can come? See, when you apply the load this way, simple support can give upward reaction. But when you apply couple, one side, it will try to get lifted. So reaction is down. Some will argue, sir, it cannot give reaction because it will separate. No, in that case, that simple support should be a hinged support. Hinge can take reaction, or you should place the simple support above the beam. See, place the simple support above the beam this way. Then it can give what? Downward reaction. Or if it is a roller support, again same thing. Simple roller, get lifted. No. there will be some connection like anchor bolt, etc., which will prevent the lifting. So that all we are not bothered here. That you consider when you go to design field. In the design field you bother it. So here, whether whatever is there, we will consider vertical reaction. How to consider vertical reaction, how to calculate, what is sign convention, each and everything thoroughly explained. Therefore, now I will start first for simply supported beams. Okay, I will remove everything now. Simply supported beams. I will give only vertical reaction. Every simply support beam, left side I will call A, right side I will call B. Span will be L for standard cases. Span or length will be L. And remember, my symbol is, if it is a point load or a concentrated load, my symbol is capital W. Whereas if it is UDL or UVL, then symbol is small w per unit length. Unit length, that is the intensity. When I put the sketch, I will dictate, but I won't write statement, because when I was giving earlier bookwork types, when I was solving that one, I wrote each and everything. W with the intensity of load. I explained types of loads. I took nearly 7-8 classes. See how much I covered for types of load. So therefore, this is actually revision type. So now I will start simply supported beam. Maybe today, little late now, I may stop at simply supported beam today. Maybe and simply supported beam, overhang beam. And if time permits, I will go for cantilever, or cantilever, I will go for a separate class. Okay, now, remember now, I won't write again and again, standard cases, first simply support beam. When I complete, I will write once again, standard cases of support reactions for cantilevers. There also, horizontal reaction, we are not bothered. But one more thing is there, if inclined load is given, you have to resolve horizontal and vertical load. For vertical reaction, you consider the vertical load. Horizontal load will create axial force. It will not create shear force bending moment. That all we will discuss in SFD VMD. So now, I will start everywhere. I will put the case here. Sketch I will write in the black color. Below I will write answer, reaction in red color. And remember, everywhere, vertical reaction will be symbol. Simply support beam. Vertical reaction at left end, my symbol is VA. Vertical reaction at right end, my symbol is VB. And I won't write plus minus. You solve the question. If you know the sign convention, suppose you assume upward, if it negative comes, it is downward. That's all I told earlier. So direct answer, left VA, right VB. When I go to cantilever, V and M, H I am not writing. If it is left side fixed, VA and MA. If it is right side fixed, VB and MB. That way all I will give now. Therefore, now I will start one by one, correctly go through, make a full fair copy, and at least now realize the importance. Just one more thing, out of subject. You know, I give notes for each and everything. Complete subject I give notes. Engineering mechanics, remember, I already uploaded or distributed notes 100 pages, first 100 pages. You may note the 100 pages will cover only 2 or 3 classes. See, engineering mechanics starting part 1, just class to 2 or 3 or 4 I think. That is, the notes will be very huge notes, considering each and everything with a lot of explanation. Why I am telling? Because not asking you to get the notes. Those first 100 pages, I made it public. See, I announced there. You go to playlist, there you see systematic course, something like that, I don't remember now. There you can see engineering mechanics. There first I have seen details of the course for engineers, details of the course. Then I told details of notes for the course, and also then how to get the notes for the course. I don't want to tell here, there's a nominal charge for the notes, engineering mechanics, strength of materials and structure analysis all together. Number of pages will be surely more than 3,000. By the time I finish all some entire subject, 3 subjects, it will be more than 3,000. Means so systematic and so in detail will be the notes. Now, Why I am telling? Because so many people registered. I sent first 100 pages. That anybody can access. But now onwards, 101 page onwards, I am sending only for those who are registering for it. How to register, you can see there. Then others all should see the class and prepare their own notes. Someone told me, sir, it is very difficult. Then you have to buy the notes. I will tell, I don't know if it's a buy. In that case, you have to sacrifice little. Some little you have to lose. Lose means financial loss. Little you have to spend for it. Okay, now my appeal is for those who already registered. After sending 100 pages, if they are going to this class, then because of the same problem I told, health issues all, I could not complete. So, but nobody complained so far. They all had got confidence in me that sir will give. Right now, I started writing systematically notes, updating it, and I need at least some 2 weeks time to update next 100 pages. So, by the end of this month, I will give notes, I will distribute for those who are registered, notes, page number 101 to 200. Then again within 1 week, I will give 201 to 300. That way, finally a day will come when how much I covered in the class, notes also will reach there. Then become perfectly matched. Because I told I never give the notes in advance. I give the notes after taking the class, because what I wrote in the class problem, that also I am transferring. Sometimes the notes I will write. For more details, refer the class. Therefore, now it is a lagging behind. See, class is here, notes is here. A day will come when they will catch up. Then onwards, nothing to worry. 1 week I will take the class. End of the week, that week class, notes I will give. Okay. If those who want, suppose you feel you require the notes, go through the playlist, go to details. There are given details of the notes. Go through it and then decide what you want. Okay. Now I will start standard cases. Start now. I told case explanation with the answer. Simply, you can write standard cases of support reactions for simply support beams, only vertical reactions. Everywhere L means span. I won't waste time. Everywhere L means span. If I put capital W, see, some people for capital W, instead of they will put P. Okay, no problem. You can use P also. But I prefer W. Capital W is my symbol for magnitude of concentrated load or point load. But sometimes, if the total load given, see, for UDL, W, small w is standing for intensity of UDL or UVL. It can be uniform or varying, will come later. That is W per unit length. See, I never write W kilonewton per meter. I never write span in meter. It is all nonsense. In the standard cases, using kilonewton and meter is utter nonsense. I already told earlier, they should think a little. Standard cases, there is no unit. Therefore, you should never use kilonewton, meter. Why? It can be anything. That is, see, area of a rectangle is base into height, or triangle. See, simple. Half into base into height. No one will tell area of a triangle is half into base in millimeter into height in millimeter. Anybody will tell why it can't be in meter? It can be in kilometer also. So when you tell area or linear dimensions, you use L. It can be micromillimeter, millimeter, centimeter, meter, kilometer, light years, anything. Therefore, I advise everybody, those who are giving such standard cases in future, those who go through my class, in future, never write W kilonewton per meter, W kilonewton. No, wrong. It is technically wrong. But example you can give. See, for example, if W is in kilonewton per meter, if L is in meter, the bending moment will be WL square by 8. It will be in kilonewton meter. That you can tell. But you should not tell standard case simply support beam of span L meter. What is that L meter? Why a meter? Okay, leave it. People will understand one fine day. Start. Like that, so many mistakes are people are doing. I will highlight one by one. Okay, start now. Central concentrated load means load at the midpoint, point load, W. See the answer directly. VA W by 2, everything explained earlier. VB also equal to W by 2. Why means I won't tell. This I did earlier. Okay, now. Eccentric concentrated load, W. It is center, here L by 2, L by 2, here. From one side A, other side B. Suppose the B is not on it. I'll give reaction now. Reaction, answer. W B by L, that is VA, VB equal to W A by L. See, I am not writing this A. This all will repeat here. I won't write once again. Same sketch I am writing. Now, this I told you. This reaction is load into other distance by span here. Load into other by span. Now, make a note. Suppose A given, B is not given. Then you should not write B. This is WA by L. This will be W into, instead of B, you write L minus A. See, use, or it is W into L minus A by L if B is not mentioned. B is not mentioned. That is, 1 minute. Let me see the camera first. I came too much down. Oh, yes, visible. Okay. That is, suppose the question is simply support beam of span L, point load of W at A from left end or N end. Then this way. Okay, now two symmetrical point loads, W. Say S from here, S from here. I don't want to use A. Usually I use A, B for eccentric. Both are equal distances. Direct answer. VA equal to W, total load divided by 2, that's all. VB equal to W. Okay. This will complete concentrated load. Now I'll go to, usually sometime I write earlier to save the time. Okay, rub and write now. Next I'll go for, this is for point load, you can write here. First for concentrated loads. Concentrated or point load. Okay. That's all, not further. These are the standard cases, point loads. Now, I rub and write here to save the time. This I will remove now. Why? How many times I have to tell? Same thing again and again. You write it. Okay, now consider UDL. UDL means small w means intensity. Intensity of UDL. Actually, I will write it as W per unit length. Okay, start. First, UDL over entire span. See here. L. W per unit length. A and B. Answer. VA WL by 2. Why? Because total load divided by 2. Total load is W into L. Sorry, I should not waste time. This all explained so many times earlier. AB. This is the answer. Now make a note. Suppose instead of intensity if total load given. This also I told you, total load is given. How to get the answer? I already told earlier. Say W, total. This is a total load. Then, I explained earlier, see, this is a beam. Because sometimes, especially in competitive examinations or academic questions, they tell you a distributed load over uniformly distributed load over entire span, comma, total load is W, they will tell. Means span L, they will not give intensity, they will write here total load or simply total equal to W. Means your intensity is W by L per unit length. Okay, now answer. W by 2. VB also W by 2 over. Okay. Now, I'll do one thing now. I'll rub now UDL over not entire span. UDL starting from one end. This is a standard case. You should remember it. Starting from one end and extending up to center. Okay. Now I will give two cases here. See, little small I will write. I will give more explanation. See here. You simply supported beam, little smaller. Okay. Space problem. AB, span L, starting from one end. See here. Stop. Loaded length is L by 2, exactly L by 2. Intensity is W per unit length. See. Or it can be also this way. See. W per unit length. AB starting from right end, extending up to center. L by 2, total is L. Answer. This you should remember. I told earlier how to get the answer for this case and remember it. Principle is told for you. See, I won't write an answer or give something without explaining it. I never do it. AB. It is intensity VA equal to VB here. VA equal to VB. See now, I never by heart. If I want the answer, I will replace this by WL by 2 load here. WL by 2 load here, this is 1/4, this is 3/4. 1:3, it will get or it will be transferred to either support. This is all I told you. So this reaction will be 3 by 8 WL. This will be WL by 8 or 1 by 8 WL. This is where load starts 3 by 8 WL. Earlier class I told it. Here this will be 1 by 8 of WL. This will be 3 by 8 of WL. WL by 2 into this reaction if you want. WL by 2 is the total load into other distance is 3 by 4 of L divided by L. 3 into 4 is 8. But that I won't do. This all explained. Okay, this is over. Now, 1 minute. Make a note. Now, you write everything, make a fair copy. Now write. Now, suppose total load given. I will make here only to save the time. total load given. Say W means you write the sketch once again. Instead of intensity, they tell total load is W. How to get, I told you already here. See, this all you require hard work and dedication. Total load given equal to W. Then the reaction will be VA will be 3/4 of W, VB will be 1/4 of W. VA will be 3/4 of W, VB will be 1/4 of W. Here, this reaction VA is 1/4 of W, lesser reaction. No L. Yes, no L here. L will not come. 1/4 of W. This reaction VB will be 3/4 of W. Why 3/4? Because see, this is L by 2, L by 4. This is L by 4, this is 3L by 4. 3:1 reaction will come here. Other distance is to this distance is this reaction is to that reaction. But anyway, I need not tell all those things. Okay. This is also over. UDL starting from one end over. Now, UDL for partial length L or for a length L, for a length not L, for a length S, but symmetrically placed. If it is not symmetrical, symmetrically placed. Okay. With W is the intensity. Now, if it is not symmetrically placed, it is not a standard case. Then you have to do sigma m0, sigma v0. That all we have done earlier. Standard cases, see here. Any length. See, this span is L. Loaded length is S. And remember, if it is S, intensity is W per unit length. See what happens is the center of the load S by 2 this side and S by 2 this side. S by 2 here and S by 2 here. That see, loaded length is S. Yes, this is exactly center. See, symmetrical. How much load this side, that much load that side. Answer. I think I'm feeling little tired today because I told I'm okay. I took a lot in the afternoon time. You know, it is night time. I took a marathon class for around 4 hours. Therefore, I will stop off this example VB directly WS by 2 WS by 2 over. Why? Total load W into S divided by 2, half of. Now, by chance, make a note here. By chance, now, if instead of intensity, total load given, say W, then see here, they will tell you total W, total equal to W, total load equal to W. Then answer is symmetrical. VA equal to W by 2, VB equal to W by 2 over. These are the reactions. Now, I thought I will continue some more for uniformly varying load and couple, but I am uploading the class after a very long time. And because of a pre-document today, a lot of classes I have taken, feeling little tired, and it's already late night. So at least we started today. We should be happy. Course started once again. So tomorrow, next class, I will continue. I will tell you UDL over, I will change over to UVL. this type or this type or this type, then I'll go to couples, then overhanging case, then cantilever. Most probably next class we can complete the standard cases. Okay. Now, be serious. I see I am putting so much of effort. I am telling earlier, correctly understand, solve. And one more request from my side. I am seeing my class is not reaching much because I don't go for publicity all. So one favor from your side. See, I will not ask you like the video, I will not tell that way. Or write a good comment for me. No. You are not commenting much. But as much as possible, share this one to people known to you. Let our class reach many possible so that let it spread over the entire world. I want it. I know if not today, one fine day, it will happen. It will take time. So your support is required. Okay. Thank you. We will meet in the next class.